Okay, hi everyone. I'll just move myself down here. Thank you for joining me. So we're going to be getting back now to our video series here on Introduction to Firewalls. So hackers, we all know they're out there, and we also know that they're out to get us. Every week it seems we hear something about yet another attack or a new virus spreading over the internet and causing computer problems. You know that you have to protect yourself, but before you can do anything, you have to know exactly what the dangers are. The better informed you are, the easier it'll be for you to assess each threat that you encounter and protect yourself against these threats. This chapter helps you to understand the most common types of attacks. Don't worry, we don't get into the gory technical details of each type of attack, but we examine each of the most common attack types. Armed with this knowledge, you can assess what type of defense may be best suited for each attack. Intrusion attacks. The most feared type of attack is an intrusion from outside the organization, where someone breaks into your network and gets access to your computers. An intrusion is also the most obvious type of attack, and almost everyone who considers installing a firewall initially does so to prevent unauthorized access to the internal network. Before you look at who would want to get unauthorized access to your computers, look at why an intruder might want to access your computer's confidential data. This includes anything from sensitive financial data to the blueprints of your next confidential engineering project. You'd be surprised to know who might be interested in this information. For example, this person may be a competitor or a hacker who plans to sell the data about your new perpetual motion machine. Sometimes hackers try to access confidential data just to show off their technical prowess, to show their friends that when they weren't supposed to go. Cases have also been reported of foreign intelligence services trying to garner confidential data about projects that might help companies in their country. Although only a few companies need to worry about a snoop from a foreign country robbing them of their intellectual property, remember that interest in confidential data may come from expected as well as unexpected sources. Customer data. Many companies store data about their customers on their corporate network. Obviously, this information could be useful to the company's competition. It may also prove useful to a hacker who doesn't care much about your customer list per se, but rather about information related to customer payments, primarily credit card numbers. Some hackers have been known to go on a shopping spree using credit card numbers that were stolen from company sites via the internet, and some hackers specialize in stealing credit card information from company websites and extorting money from these companies in exchange for not telling the affected customers that this company neglected to store their customer data sufficiently. Computer resources. Hackers may be interested in taking over your company's resources for their own use. The computing power of your computers may be just what the hackers want, because their computer is not sufficient for the task that they are trying to perform. A way to hide their tracks. Hackers may actually want to break into someone else's computer, not yours, but they don't want to get caught. A good way to perform this type of intrusion is to launch that attack from someone else's computer, yours. After a hacker has taken control of one of your computers, he is able to launch the next attack from there. If he gets caught, all the tracks point to you, and you'll probably have to do some explaining when attacks on another computer system appear to originate from your network. Denial of service attacks. A denial of service attack makes a service that a computer provides unavailable. For example, in early 2001, users all over the internet weren't able to connect to Microsoft's web servers. Many people were wondering what happened. Actually, all of the web servers were up and running but nobody was able to connect to them. The problem had multiple causes, including the fact that a hacker or a group of hackers attacked the network that contained Microsoft's domain name system DNS servers. Because users could not connect to the DNS servers, these servers were unable to direct anyone to Microsoft's website, which caused legitimate users to be denied access. Any type of attack that is designed to prevent the legitimate use of a computer resource is referred to as a denial of service attack. Sometimes it is abbreviated as DOS. Some types of denial of service attacks include preventing users from making a connection, crashing a computer, overloading a computer with so many connections that it can't answer any legitimate connection requests. Denial of service attacks can be unintentional. A computer worm known as an SQL slammer rapidly spread around the world one Saturday morning in January 2003. This worm was designed to do only one thing: spread as rapidly as possible. In the process of doing this, it also created so much network traffic that it slowed down all other internet traffic and even prevented people from using ATMs that depend on communicating with a central computer. A denial of service attack comes in many variations. It may target a single computer, or it may prevent access to an entire network of computers. DOS may mean shutting down a web server or overloading a network connection with too much traffic. No matter how large the scope of a denial of service attack, in each case it is intended to prevent legitimate users from accessing network resources that they are allowed to access. Distributed DOS attacks. A distributed denial of service DDoS attack takes the denial of service attack one step further. Sometimes a denial of service attack involves overwhelming the target computer with so much network traffic that it can't respond to legitimate connection requests. As you can imagine, generating enough traffic to do this can be a challenge. However, if enough hackers band together and coordinate their actions, or even if a hacker is able to commandeer enough computers, then the hackers may be successful in generating enough traffic to make it impossible for the target computer of the attack to keep up with it. Because such an attack is launched from multiple computers that are most likely distributed all across the internet, such an attack is called a distributed denial of service, or DDoS attack. How hackers get in. Hackers have a number of ways to get into computers and networks. Most operating systems or other programs have vulnerabilities, and it is only a matter of time before someone discovers them. This section explores some of the most common techniques that hackers use to attack computer systems. Insecure passwords. Before looking at some of the more sophisticated techniques that hackers use to break into your network, you should realize that most intrusions are made possible by simple carelessness. Just as burglars find it easy to break into a house whose occupant has placed the key under the doormat, breaking into a network is easy if you use passwords that are easy to guess, such as the word password, a blank password, or a default password provided by a standard software installation. Before you start worrying about sophisticated high-tech methods that hackers can use to break into your network, you should consider all the simple flaws in your system, such as insecure passwords that may represent even greater vulnerabilities. This should go without saying that never write down a password anywhere. If you have, please correct this habit immediately, because it presents a severe security risk. You can follow many guidelines for selecting secure passwords. A good rule is to choose a password that is easy to remember but difficult to guess. A good password may be based on a combination of a name of a childhood pet and a phone number and a distant relative. Both of these facts are difficult for people to guess, but You remember the components of the password quite readily. You also have to consider the automated password cracking programs can do. Hackers may intercept a network transmission that contains data that has been encrypted with a password, or they may intercept logon traffic to a computer that includes a username and a corresponding password. After a hacker has this information, he will try to crack or guess the password. Often this process involves using a program that tries to guess the password first by trying every word in the dictionary and then trying a possible combination of characters. Because computers can guess hundreds or even thousands of passwords per second, automating this procedure is much more efficient than manually typing in a large number of guessed passwords. The only way to protect against a brute force password cracking attack is to select a password that is sufficiently complex so that a password can't be found in a reasonable amount of time. You can do this by selecting a long password, 7 characters or longer, and by using a combination of different characters, uppercase and lowercase characters, numbers, special characters. You should also change all your passwords on a regular basis in order to minimize the amount of time that a hacker has to crack a password and the amount of time that he or she can use the password. Default configurations. Surprisingly, many software default configurations contain potential security vulnerabilities. One reason for these vulnerabilities is that software vendors often place a priority on making their products easy to use, and as a result, security may take a back seat. Also, vendors often feel pressure to get new software or hardware to the market, whether it has been sufficiently checked for security flaws or not. Another problem with default configurations is that they are easy to predict. For example, some database programs ship with a default user account and password to administer the database. Because this username and password are the same for everyone who installs such a program, they are easy to predict unless you specifically change such settings. Hackers can use some predictable settings to attack most instances of the database. Sometimes you can protect yourself against weaknesses in default installations. So that should be an S there. By changing some defaults such as blank passwords that is used for an override account. Sometimes you need to apply security fixes that a vendor has made available after the product was released. You can get information about security fixes from software vendors. Bugs. In a perfect world, all software would be flawless. Unfortunately, we don't live in a perfect world, and built-in errors or bugs in computer software or hardware are a fact of life. If you've ever had a program crash while you're in the middle of doing some important work, you know how annoying bugs are. With the complexity of today's software, it is almost unavoidable to have any software without bugs. Hackers can use bugs in programs to get these programs to crash, which constitutes a denial of service or get unauthorized access to a computer. One type of bug that hackers exploit is a buffer overflow. A buffer overflow condition can exist when a program allows a user to enter data and set aside a limited amount of space for the data that the user enters. This temporary holding area for data is referred to as a buffer. A well-written program checks the length of the data that is entered and rejects any user-entered data that is longer than the buffer. A badly written program accepts data that exceeds the maximum allowed length. When a user enters data into a badly designed program and the data exceeds the maximum allowed data length for the buffer, the program overwrites data that is located in the computer's memory that is adjacent to the buffer. Writing arbitrary data to your computer's memory can have a number of results, from crashing your computer to inserting another program into your computer that could give an intruder unlimited access to the computer. For example, you may be able to send an extremely long command to a web server that causes a buffer overflow on that server. Hackers have found ways to exploit buffer overflow bugs in order to crash or take control of computers. Fortunately, most software vendors nowadays are much better at checking their software for buffer overflows than they used to be, but buffer overflows still occur on a regular basis. Bugs are a fact of life, but most reputable software and hardware vendors review their products based on customer feedback and their own testing, and then release bug fixes shortly after a vulnerability has been detected. Of course, there is no guarantee that a hacker has not found a bug before the vendor has released a fix, but by promptly applying a newly released security fixes, you can preempt most hackers. Most successful intrusion attacks take advantage of known security flaws for which fixes are available but not implemented because administrators of the affected systems were too busy or too uninformed to do so. Virtually every computer attack over the last few years that you have read about could have been prevented if people had updated their computers. Code, Red, Nimba, SQL, Slammer, and many other attacks exploited computer bugs for which fixes were available when the attacks occurred. Most people in the security community who look for vulnerabilities for academic purposes or to stay ahead of hackers abide by a unwritten rule. Anyone who discovers a bug in a product should always contact the product's vendor first and give the vendor the opportunity to fix the bug to develop a fix for the bug before announcing it publicly. This means that the details of the security flaw are often announced only after a fix has been made available. However, unscrupulous hackers may share flaws that they discover with the vendor but try to exploit such flaws for their own gain. Backdoors. Some software developers have been known to leave backdoors in their products. A backdoor is a way to get into a program bypassing certain security features. An example, by including a hidden user account with a high level of privilege. A backdoor may be used during the software development process to bypass some security settings and to get easy access to some program features that should be restricted during normal operations. Unscrupulous programmers may leave a backdoor for themselves so they can get unauthorized access to the program after a customer is running it. Some unscrupulous programmers have been known to leak a backdoor in a program they developed for a client so that they can disable the program in the event of a dispute with a client. After a programmer has created a backdoor, a hacker may discover it and use it to access a computer system. Unfortunately, such backdoors are becoming increasingly rare. Another kind of backdoor is also becoming increasingly widespread. Programs such as NetBus or BackOffice are essentially remote control programs that allow a hacker to gain complete access to your computer over the network without you knowing about it. Such programs may record every keystroke on your keyboard or network traffic to and from your computer. You may wonder how such backdoor programs get on your computer in the first place. In most cases, a computer virus or a Trojan horse places them there. The next section explains how these type of programs operate and why they create serious security dangers. Viruses. It seems that not a day goes by we don't hear about a new computer virus. It sounds scary, and indeed it is, but we explore the dangers of viruses, worms, and Trojan horses. A virus is a computer program that is designed to spread itself from one file to another. The effect can range from benign to catastrophic. A virus may just spread itself and never have any other effect. More likely, a virus makes itself noticed in a variety of ways, ranging from displaying a message from the computer's creator to destroying data on your disk. Viruses a variety of ways to spread from file to file. A few years ago, the most common method of spreading a virus was by sharing floppy disks. If the floppy disk contained an infected program and the recipient ran the program, the disk infected other programs or the system area of a floppy disk. The file or the disk may then be shared with other individuals and infect files on their computers. With the advent of the internet and popularity of email, floppy disks are no longer the most common means of virus transmission. Files can be exchanged much more easily and sent to a much larger number of people in email or via file downloads. These new ways to spread viruses have made them much greater threat than they used to be. Worms. Worms are similar to viruses, but instead of spreading from file to file, they spread from computer to computer. Worms have also a method of copying themselves to other computers, either by connecting to other computers over a network or by email. Sometimes worms even do so without any human intervention, and sometimes the main purpose of a worm is to actually infect as many computers as possible and to spread as rapidly as possible rather than destroy data. Nimba, Code Red, and SQL Slammer are some of the most well-known viruses. Trojan horse. A Trojan horse, just like the wooden creature in the old Greek saga, comes as a gift that contains something unexpected. Just as the Trojans were too excited about their gift horse to look it in the mouth, all of us tend to be too trusting at times. Someone who designs a Trojan horse program preys on this trust by packaging a nasty surprise inside a program that looks interesting to someone who receives it. Suppose that someone sends you a program that plays a funny cartoon on your computer. After you get a good laugh out of it, you forward this program to your friends. You forward it even further. However, while you were laughing at this cartoon, the program also modified your computer. Not only did it install a backdoor that allows others to access and control your computer over the internet, it also announced the availability of your computer to the author of the program by sending a message to him. This much publicized love bug virus, a virus named after the Russian tennis star Anna Kournikova, are examples of Trojan horses. Man-in-the-middle attacks. One type of network attack referred to as a man-in-the-middle attack involves intercepting a legitimate connection between two computers and then hijacking this connection. Often after a user has established a connection to a server, the server assumes that all network traffic that arrives over this connection originates from the user who establishes the connection. When a file or other resource is accessed, access is granted based on that user's privileges. Some network attacks involve listening in on the connection and then sending network packets to the server. In these network packets, the hacker's computer impersonates the original computer. If such an attack is successful, the intruder gets all the access that the original user was granted. Fortunately, man-in-the-middle attacks require significant technical sophistication, are not easily accomplished. Impersonation. Impersonation involves a computer or a website that is run by a hacker, but that appears to be another website. For example, a hacker may create a website that looks like a popular shopping website that collects users' names and payment information as users are entering them on the website. Other impersonation attacks may involve the collection of usernames and passwords. Redirecting a user to a different website can be accomplished by changing information on DNS servers, by getting someone to click an innocent link an innocent-looking link on a website or by a number of other methods. Fortunately, successfully impersonating other computer systems is not easily accomplished and requires a lot of effort. Eavesdropping. One technique that intruders use to attack you involves eavesdropping on your network protocols that use clear text transmission to send a password, such as the file transfer protocol FTP, are most susceptible to eavesdropping. Most networks rely on shared media, in which any computer connected to the network cable can potentially listen in on all network traffic that goes across the network cable. Unless this network traffic is encrypted, anyone with sinister intentions can record the network packets that are exchanged between other computers. This allows anyone with physical access to a network segment to eavesdrop on the network traffic that flows across this segment. This may include users inside your organization or someone who can plug a computer into a network connection that's located in unattended locations, such as a lobby or an unoccupied conference room. Outside intruders may also get access to your network in order to eavesdrop. Often outside access occurs by getting a legitimate user to inadvertently run a program that sends recorded network traffic to the hacker. In many cases, the employee is not even aware that this is happening. A virus or Trojan horse program installed on the listening program, even out on the internet. Someone may be listening in on network traffic between your computer and a computer on the internet. Because of the distributed nature of the internet, you have no guarantee that someone else is. Inside jobs. Firewalls are a great way to protect your network from dangers that originate from the internet and keep intruders out. However, relying on a firewall as your only protection can give you a false sense of security. Remember that your network faces other kinds of threats, and one of these threats comes from legitimate users who are doing illegitimate things. This can be someone trying to look into a co-worker's files without being allowed to do so. It could also be a user who brings in a program from home that, unbeknownst to other users, creates a backdoor into your computer network. As important as it is to have a firewall that protects your network, just remember that even a well-designed firewall can protect against some threats. Other techniques. Hackers can use a wide range of other techniques to get into your network, and some of them are not as obvious as others. No matter how well you understand certain types of threats, remember that numerous others exist, including some that have not even been discovered yet. Social engineering, for example, is a term that refers to tricking people into giving access where they shouldn't, or getting people to share information that they shouldn't share. Suppose you are doing your desk job at Megacorp, and one day you get a call from Fred Smith, who identifies himself as a manager in the information technology department. According to Fred, someone broke into Megacorp's user account database and stole some passwords. Unfortunately, your password was one of them, and Fred needs you to change your password right away. To make sure that the new password is complex enough to provide sufficient security, Fred suggests a new password for you. Of course, you are happy to help Fred secure your company's network. You change your password, the one that Fred suggests, and you soon forget about this call. At the same time, a hacker across town tells his friends about how he pretended to be Fred Smith to get a password from an unsuspecting user at Megacorp. He then proceeds to use this password to dial into Megacorp's network and dig for data that interests him. Some hackers have found that they can hide their tracks by creating false alarms. Many organizations have methods to detect intrusion attempts and to alert a network administrator. Some hackers have found weaknesses in such systems and perform activities to create thousands of false positives, thus hiding their activity among the many false alarms. The challenge for the network administrator is to find out which attack is the real one. Can a firewall really protect me? Does a firewall protect you against the threats we described in this chapter? The answer is not straightforward. A firewall is indeed a very effective method of protection against many of these threats, but not all of them. Remember that a firewall is placed between your internal network and the internet. A correctly configured firewall can prevent unauthorized traffic from entering your network and keep your data from leaving your network. These two functions can prevent hackers from accessing computers on your network and from stealing data from your network. And they may even prevent computer viruses from making it into your network. However, a firewall does not protect you against attacks that bypass your firewall, such as a hacker who walks into your office building or an employee who inadvertently brings a computer virus to work on an infected floppy disk. So I'm going to leave it here this evening for this video. Please like, share and subscribe. Thank you.